All right, temperature is one of the first things here in thermodynamics. I kind of explain a lot of it in my notes. Please look through how to convert between the temperature units. It's a very useful thing to do, and you can look through those and how to do that. What I want to spend more time here is talking about expansion. Just note here that when you do heat something up in general, when you heat something up, it'll expand. And it expands according to the formula given there, which is that change in length is equal to alpha, the original length, times change in T. This temperature change has to be in units of Celsius, or it could be units of Kelvin because the change will be the same. The original length and some constant according to the material, the type of the material. And here will be the change in length. Same with change in volume. It's very similar. Change in volume will be equal to another constant times V naught change in T. Okay. In fact, this constant only comes from the fact that we're taking the length times the width times the height. We're actually just cubing this to get this. Okay, so they're actually relatively the same. What I want to point out here is that yes, if you heat, if I have an object here and I add temperature to this and I heat this up, okay, or actually I increase the temperature, not add temperature, but if I increase the temperature of this object, it might grow a little bit to about here. Okay, so it'll get a little larger. It'll extend. It'll have some change in length right here. The interesting thing that will happen here is in terms of volume. Okay, and I wanted to show you something. If I had a sphere, okay, and I heated this, here's a nice sphere here. If I heated this sphere up, this metal sphere, let's say, it'll increase by volume by a certain amount. Okay, so it'll increase in volume depending on what its constant would be, its original volume and the change in temperature. It'll increase. The interesting thing happens here is that if I have, let's say, a flat disk, okay, it's a flat circular disk. If I heat this up, okay, it'll expand, and it'll expand linearly. The weird thing that happens is, what if I add a hole to this? In other words, if this was like a washer, okay, if this is a washer and I heat up this washer, so in other words, this is all the solid part, just to show you here, this is all the solid part, but I heat this up, there's a couple things that people are going to think are going to happen. Okay, there's two scenarios here. One, well, yes, if I heat this up, in fact, this will all expand and actually fill up the hole and actually start closing it up. Even though this will expand out, this will expand in and actually close up the hole. This is in fact not what happens. What happens here is, in fact, you treat this just like there was metal in here. In other words, treat a washer shaped like this just like it was a solid disk, okay, as if it was like this. And this hole will expand as if there was just metal like this. In other words, this metal is going to expand linearly. Same with this. This will expand linearly and the radius will get larger. Treat it the same. Just understand here, it's not the scenario where the hole gets smaller. In fact, it'll get larger. It's a little trick they like to do sometimes on the AP, but just be well aware of that.